What information is useful when defining your problem, and how to include that in the dataset? Imagine a pose recognition problem based on computer vision. We detect the person in the video and classify his posture. In this example, the classifier is trained on features extracted from the human torso model. This is our data. All additional information we may collect, such as pose labels, person name, or frame number, is metadata. Data is what we learn from. It is the only input of our classifier on a new video frame. Metadata is everything else we collect when designing a classifier. How to import this information? Say our videos are stored as separate frame images in person directories. The feature representation for each person is stored as a comma-separated text file. We can import numerical data and numerical or string metadata into MATLAB using the sdimport command. We add the second person and we concatenate the per person dataset. Let's import all persons. Beside the pose label, we have included also the person and frame information. Let's see why this metadata is useful. We can visualize and inspect the problem. Using sdscatter, we focus on a specific pose class. We can see which person performed that pose. We can use the sample inspector to view all metadata of a sample. Because of the metadata, we can understand the structure of classes in our dataset. For example, we can easily test if each pose is represented by several persons using the confusion matrix concept. On the rows is the person, on the column, the pose label. Pose 3 is actually underrepresented. We may remove that from the analysis. How will our pose classifier be used? A new person will come by to play a game. Therefore, our classifier must work well for new people. To make sure we evaluate classifier performance in a realistic way, we need to have different persons in the training set and in the test set. This can be easily achieved using our person label. Our dataset contains data of 13 persons. Let's simply take the first 8 persons for training and the remaining 5 for testing. With the metadata, we can also understand why the error occurs. Let us build a simple linear classifier, execute it on the test set, and visualize the confusion matrix. Pose 9 is actually often misclassified as pose 1. We may add the decisions into our test set as a new label and visualize it in the scatter plot. Now we may constrain the view only to pose 9 and switch to person labels or decisions to understand more. We may see that all errors come from one person. Why the errors happen for Salim? Could we access the original video frames? Yes, because we have stored the person and frame information in the dataset, we may actually visualize the video frames corresponding to any sample. With a custom callback function, we may load the respective frame image and show it in a separate figure. This helps us to see that the misclassification happens because of an error in the hand detector. Summarizing, we have learned that it's very easy to bring metadata in per class, and that this additional information is fundamental to understand the structure of classes, to realistically evaluate classifiers, and to understand why classifier errors happen. Thank you for your attention.